All right, welcome to session 12 of Project Management Professional Training Series. So session 12, we are going to touch base a little bit on the schedule compression. So schedule we have completed with all the examples on critical path till session 11. But 12, we are going to just touch base the last tail end of the piece, which is schedule compression. And then we are going to step into the third of the triple constraint, which is cost, right? So, all right, cost, we are not going to do it in one session, of course. We are going to spend at least 2 or 3 sessions on cost, but let's start off the basics and the fundamentals of cost, and then let's also do some cool stuff like schedule variance and cost variance, and followed by a calculation. Okay, schedule compression. Now, day in and day out, when you join meetings with your leaders or your program managers or your bosses, one of the most common ask in the call might be how to compress the schedule, how to ensure that things are not falling to the right and they are coming more to the left hand side. Or let's say that you're working for an external client, and the client in the middle of the program, tells you or requests you that, hey, could we shift the schedule to the left hand side, or could we compress the schedule a little bit more? Okay, well, this all will need, like in the middle of the program or the project, if you want to compress it or if you want to change the go live dates, then it surely has to go through the change management board or the change control board, and it has to get the approval from the sponsor, right? Because any of the item, the key baseline changes, be it the scope, be it the time, or be it the cost, any of these changes in the baseline will lead to approval from a sponsor. Without that, you cannot proceed forward, right? But schedule compression is also a good technique to ensure that you're achieving more in less time. However, there are risks associated with schedule compression always. So let's see. Now, there are two kind of known ways when we want to compress a schedule. One is called the fast tracking, and one is crashing. The fast tracking is more or less, I will say, the plain and simple logic, right? The common sense. So in any program or project, when you want to work with activities, either the activities has to be worked in parallel or in sequence. The sequence means that either there has to be a dependency, a hard dependency, or a soft dependency, right? But things can be done in parallel as well. So we keep on saying that if certain things can be done in parallel, let's do them in parallel if there is no dependency on each other, which is, of course, a very nice way of doing things. Let me pull out an annotation and quickly show you what do I mean with a compression here. So if you look into these items, let's say activity A and then B and then C, right? Each of them are having the duration. So let's say 10, and this is 15, and this is 15, right? What we are doing is that we are telling that, okay, C is not having any dependency on B. So what can we do is that we can start off A, and then B and C can be done in parallel, and both B and C can be finished in 15 days. Okay, now sounds good and looks good, right? Now, what's the problem here? Why the risk is getting increased in this kind of a solution? The risk is getting increased because your focus is getting shifted into multiple paths. Probably it's easier to focus on one single path rather than 3 or 4 paths where things are moving in a direction from left to right, and then having a control on them, or having the exact way to mitigate any kind of particular risk falling on them. Let's say activity B has a risk and you plan to finish off B completely and then push on to C, right? Which is fine. But let's say activity B has a risk and C has a risk as well. Okay, inherent risk of the activities. Then you have to focus on B and C to register and to mitigate the risk at the same time. When you're doing things in parallel, your focus gets shifted and you are kind of doing multitasking. Even probably it may also happen that your SME, probably you're going to work, or you're going to finish off on a, let's say, a cloud project, and your SME on cloud, that point of time will be kind of, I will say, ironed out or distributed more into multiple activities than one single stretch of activities. So your SME can be distributed over work, and even if risk happens, then you have to focus. Your focus point also like kind of shifts by looking into various lines of work. That's the increased risk when you're doing things in parallel. Otherwise, if they are like non-critical stuff, or if they are like not having any risk, then it's always beneficial to do things in parallel. Okay. Now, let's talk about the other one, which is about crashing. So when I talk about the crashing thing, here it means that we are going to add more resources to compress the schedule. Again, a very common problem solving by any of the management. Like you talk to your senior lead and you kind of say that, okay, I can finish this work in 5 days. And your senior lead may tell you that, what if I give you two more guys there or one more guy there? Can you finish that work in 4 days? So if you're telling that with one person, you can finish your work in 5 days, which is basically 40 hours. With two-person, can you finish that same work in 2.5 days? Okay, so that kind of a conclusion comes in, but this will always lead to increased cost. Because whenever I'm trying to plant more people, let's say we have got activity A and then B and C. A is having, let's say, 10 days of duration, B is having 20, C is having 20, right? Now, when I say crashing, I mean to say that, okay, B and C can also be done in 10 days, provided we add more resources or plug in or pump in more people into B and C. And we want to complete the entire story like A, B, and C in probably 30 days and not in 50 days. So 50 is 10 plus 20 is 50. We want to put it down from 50 to 30. And if I want to do like 10, 10, 10, then it will be plugging in more people into the activities. Now, this will always lead to more cost. Why? Because the more manpower you're talking, it might be a temporary resource, a temp resource or a contractor, that will lead to a cost because you have to go and sign off a contract with the person. Or if it's even you are plugging in a person, like you're sharing a resource from some other program, then also it will be leading to cost because that other program might be having some kind of low bandwidth now for this guy, but probably if the bandwidth increases, then they also need one guy to vacuum that, to fill up that vacuum. So any which ways there will be an increase in the amount of the cost. So whenever you want to add more resources into a schedule, the ideal condition is that probably you get a resource from some other program who do not have a chance at all to the increase in the capacity, to the increase in the workload in the upcoming future. So you're fine, you can pull in this resource and 50% of sharing can be done. And in that way, you achieve your aim as well, and you do not raise the cost. But that also leads to challenges, because if you are pulling in a resource from some other program and you are telling 50% work here and 50% work there, then it may happen that his mind will be kind of distributed into two parts, and he may not be able to focus like very nicely on two different kinds of program. The most ideal is that the resource is kind of sitting idle in some project, or the project just got over and they just want to put that person into another project, and that is a sweet time, and you get this person into your project and you plug in the resource. That is the ideal, but that may not happen always, right? But crashing is almost always being agreed with the sponsor, because it will lead to more cost, and there you tell the sponsor that we are doing a trade-off between time and money. We are putting in more money to ensure that we are saving on time. And most of the time you will be seeing that the business or the sponsor, they will agree on this. They are okay with this. They're saying, okay, we are ready to plant in more dollars to ensure that the program completes on time, because uh, the more increase in the value of the dollars that they are spending, probably they are seeing a more return on investment based on the project outcome. Okay, so that's about the two ways in which we can do a schedule compression. Let me clear off my drawings here. Okay, so with that, we finish the schedule topic altogether. We'll come back to it again. Once we finish cost, then again, we'll do some cool calculations, and again, we'll bring cost and schedule like together. In the exam, you will see that most of the questions, they would have kind of combined cost and schedule concepts together. Okay, now let's get into the third constraint of the triple constraint, which is project cost. Project cost is one of the most important elements, but like I said, it goes in the sequential fashion. First, you find out the scope baseline, and you have to make sure that this baseline of the scope is absolutely correct, okay, with no errors. Once the scope is frozen and the baseline is fixed, then you get into schedule. by doing your regular activities of your stuff about the scope. You break it down into work package and then activities, the WBS thing, and then activities, and then get into the sequential part of the activities. You place them in the sequential order, put them into network diagrams, and you get into the order of, you find out the critical path and all that, right? Once your schedule is completely done, it will be very easy to plug in the cost. Because if you know each of your activity and which sequence or in parallel they are supposed to be done depending on the dependency, then you will also know the duration of these activities. And when you know the duration, you basically will be knowing how much of man hour you need and how much of the resource cost plus the services cost or the hardware or the software cost which you need for this particular activity. So I will come down on the next session on or next one about more the theoretical stuff of cost, like what are the four kinds of costs that we have. But here, first of all, let's talk about the most important stuff first, and then we can get into a little bit of theoretical stuff in the probably one of the 2 or 3 sessions that we have got on cost, right? The cost, the thing which I would like to discuss in the beginning is called earned value management. Now, EVM is something which is the core topic in PMP. Even some people say that if you have understood EVM very nicely, then probably you have got 80 to 90% of the PMP like syllabus in your pocket because you've understood the crux of the entire course content. Now, when I say earned value management, it basically means that how much value you are earning standing today on the project. Now, there are 3 key terms when we talk about earned value management. One is called PV, which is planned value. One is EV, which is earned value. And one is AC, which is actual cost. Trust me, you may not get the meaning of these values very clearly when I talk about the definitions, but once we do a calculation, once we solve a problem, I think things will be very, very easy and simple for you. So planned value actually means that standing today, what is the estimated value of work planned to be done? Let's say I'm a builder, okay, and I'm going to build a real estate, big apartment building of maybe 15 floors. And then standing today, if the project has not yet started, what is the value of work, the entire value of this work with the building cost, the construction cost, the resource costs, the services cost, all those costs when I'm adding, okay, then what is the entire value of the work planned to be done? Earned value is something standing today. What is the value of work we have accomplished? So let's say the actual value of the work was like $100. Have we completed at least $50 of the work, or $10 of the work, or $20 of the work? So how much of the planned value have we actually completed? Now, actual cost is the term which is very close to earned value, but not actually earned value. Actual cost tells that what is the actual dollars we have spent, like actual cost incurred for the work accomplished. So I know it's a little bit like, complicated now. Like it looks like earned value is what is the value of work, and actual cost is what is the actual dollar spent on the work. And you may feel that these two are a little bit very, very similar, right? But they are not. They are not actually. And once we do a calculation, then probably you will get the complete picture. What do I mean by planned value, earned value, and actual cost? So we'll go to that in detail right away. But before that, a couple of things. We're going to talk about schedule and cost variance. Now, schedule variance and cost variance are the two, I will say, the most important things with the help of which you monitor a project or a program. If it's a PMP certified program manager, or if it's experienced program manager, then he may start his meetings, his team meetings, by not telling, hey, what are the risks and what is the status, how many we are doing. He may not start all this. He may just look into the list of the programs that we are doing, and he may ask his people to plug in the schedule variance and the cost variance on the programs. Basically, we will find out in mathematical way that are we on schedule or behind schedule or ahead schedule of the project? Similarly, are we on budget, behind budget, or ahead of the budget in the project? Like, are we spending more or less, or we are spending exactly as planned, or are we going as per the planned program, or are we behind the plan, or are we ahead of the plan? These are the things they can be told very quickly with the help of some very cool formulas. So these are the earned value management formulas. And the first thing which may come to your mind is that, am I going to memorize this? Yes, you don't have to I mean, you don't really have to rote them by heart. The more you practice, you will be knowing them. Okay, it's not that you just have to say, okay, cost variance CV is EV minus AC and say it 10 times. Okay, that kind of stuff you don't have to do. But the more problems you solve, these all will be coming at your fingertips. But look at there is a similarity between the formulas, so it's very easy to remember them. Let's talk about the first thing, which is cost variance, CV. CV equals to EV minus AC. Okay, now if the EV, so any of these values, let's say the EV minus AC, the CV is negative. Negative means bad. Negative means over budget. Positive value is always good, which means that we are performing or we are earning more than the dollar value that we have pumped in, and it's under budget, right? Schedule variance is EV minus PV. So the commonality between cost variance and the schedule variance, let me just bring out my annotation here. So cost variance and the schedule variance, these two formulas, the similarity is they both start with EV. One is EV minus AC and one is EV minus PV. At least it's easy to remember that the starting point was EV, right? Then you can say, okay, the first one cost will be EV minus AC because it has to get the EV minus actual cost. And the second one is EV minus PV, or earned value minus planned value. Now, again, in the SV also, the negative value is bad. Anywhere SV or CV, the negative value is always bad because it means that it's behind schedule. The positive value is good because it means it's ahead of the schedule. Now, the third and the fourth factors are cost performance index, CPI, and schedule performance index, or SPI. The CPI means EV by AC. Now, EV by AC means greater than 1 is always good. Any value which is positive or greater than 1 is very good in CPI. Less than 1 is bad. So greater than 1 is that we are earning more than we have spent. So CPI value actually means that we are getting so much of dollar worth of work out of every dollar spent. Okay, I know it's kind of little bit difficult to get the grip in the first go, but don't worry, once we do a calculation, an example I will show you, then all these things will fall into place and I will get the picture very clearly. And the final one is schedule performance index, SPI, which is EV by PV. Again, you see there is a similarity between the formulas. CPI is like EV divided by AC. Like CV was EV minus AC. So CPI is EV by AC, right? Schedule variance is EV minus PV. So schedule SPI will be EV by PV. So whatever you are subtracting in the beginning, you're just dividing the same values to get the SPIs or the CPIs. Okay, so EV by PV, again, the same trend. If greater than 1, good, less than 1, bad. SPI value means we are progressing at this % of the rate originally planned. Okay, so as a program manager, your focus should be only on the programs where the CPI or the SPI values are below 1. If it is 1, which is as per plan, which is good. If it is more than 1, then it is better. But if it is below 1, then that's the point where you should be focusing on why it is going behind schedule, what can be done to bring it back on schedule, or why it is spending more than we thought of, or earning less than what we are spending. And then you have to think about how to manage the budget or the cost there. Okay, let me get into the, give me 1 second. I'm just taking off my annotation here. All right. Example. Now, this is the one where I would like you guys to focus on. Okay, probably take a piece of paper and write down this problem maybe, or practice it after we are done. Just go through this in a recording once or twice again and practice this entire problem completely on your own at least once or twice. Well, the moment you practice once or twice, you will see that remembering the formulas is nothing. It's very simple. And understanding the game also is very, very simple. So let me show you. It tells you have a project to build 4 conference rooms. Okay. And each of the conference room will take 1 day to build, and 100,000 US dollars has been budgeted per conference room, right? Now, the conference rooms are planned to be completed one after another. So you cannot do them in parallel. It's a sequence. 1, 2, 3, 4, right? And today is end of day 3. So if today is end of day 3, then ideally we should have completed the 3rd conference room, because it clearly says each CR will take 1 day to build. So 1 plus 1 plus 1, maybe at the end of day 3, you are done with 3 CRs, and 4th day you are remaining with the last one. But look at the status now. it tells you that this is the status on the bottom, the table which is showing. And based on this, you have to calculate what is the planned value, earned value, actual cost, CPI and SPI of this particular project. So conference room one, okay, if I say the status, the end of day 3 is complete, it is done, and it is spent 100k USD, which is exactly as per the budget, because we have told 100k USD has been budgeted per conference room. So it's being completed at the end of the day 3, which is great, and spent 100k also. Conference 2 completed, spent 120k, a little bit more than what was planned, right? And conference room 3 is 50% done, which is not good, because conference room 3 should have been completed by the end of day 3, right? And spent 60k. So it has spent also a little bit more, like 50% means we should have spent like 50k dollar and not like 60k, which is a little bit more than the half. And conference room 4 is not yet started, which is okay, because we didn't plan to start the conference room 4 by the end of day 3, right? So now let's see how the program or how the project is focusing and what are the trends in the project. So let's talk about the PV first. And if you have taken a screenshot of the previous slide, and it's great, or make a note of it, because the next slide I'm going to solve it, and we will not be having this problem in front of us, right? Now, let me pull up my annotation here. And first of all, the plan value. The plan value is the total value of the project standing, right? So the total value, should be 100 plus 100 plus 100 by the end of day 3. So if I'm only going to calculate till end of day 3, what is my planned, earned, and actual cost and all that, my CPI, SPI, then first of all, I will look into what is the planned value till day 3, which is 100 plus 100 plus 100, 300K, right? So we should have done $300K worth of work by end of day 3. Good. Now, what is earned value then? So earned value, we are telling complete on day 1, day 2 is completed, and day 3 is like 50% done, if you remember, right? So complete plus complete, 2 days, and third day is like 50%. Here you will be gauging what exactly is earned value. So it's telling 100K for complete, 100K for complete, and 50K for 50% done. Since it is 50% done, we are just dividing that 100K by 2. Okay, so this is not about the actual dollar spent. This is about, this was supposed to be the earned value at the end. This is the earned value at the end of day 3. So we have actually completed 250K USD worth of work. Remember, that is not the dollar spent actually. That is the, this value of work has been completed. Okay. I think it's clear now, right? It's pretty much like plan value is the complete plan, and earned value is whatever percentage of work you have done, what is the value of work you have completed. And then the actual cost. This is the actual dollar spent, which is the easy one. So we are telling we have spent 100K for day 1, 120K for day 2. If you remember, we spent a little bit high, and 60K for day 3. That comes to 280K. And you will see your actual cost is not the same as your earned value. Earned value is, that's the value of work which has been completed. But actual cost is the actual amount of dollars. So we have actually spent 280K USD. Now, let's come to cost variance. Cost variance is EV minus AC, which is minus 30K, which is not good, which means that we are over budget by 30K, right? Anything minus is not good, which we are over budget. And anything plus is very good, which means that we are below the budget or under budget. So we have spent by 30,000K more. And schedule variance is EV minus PV, which is 250K minus 300K, that is minus 50K, which basically means that we are behind schedule. Again, schedule variance, you will be asking me that why are we calculating that in dollar value? Well, it's just the value we are seeing here. That is the worth of value, or that's the schedule like variance. But when you look into the number, you will only look into positive or negative. If it's negative, which means we are behind schedule. Now we will see what is the actual meaning of all this, looking into the CPI and SPI. So CPI says EV by AC, okay, which is 0.89. So EV here is like 250, and AC here is 280, so 0.89. So this CPI means that we are only getting 89 cents out of every dollar we put into project. That means we are at loss, right? We are spending more and getting less. So we are getting 89 cents. If we have got 100 cents per dollar, then fine, we are as per the plan. If we would have got 110 cents per dollar, then we are earning more than what we are spending. That's a very good trend. And finally, SPI. SPI is EV by PV. So your EV here is 250K and your PV here is 300K. So 250 by 300, which is basically 0.83. Now it tells us we are progressing about 83% of the rate planned, which is not good because our rate of the progression was supposed to be 100% and and we are only at 83, like 17% less. So always remember, if we are 1 and 1, like CPI is we are getting 1 and the SPI is 1, that is the ideal thing. We are progressing on as per the rate planned and as per the dollar value planned. But if anything is negative or below like 1, like 0.89, 0.83 we're getting, that means it's bad. We are behind the schedule and above the budget. Okay. So I hope this makes things clear for you. I will advise you strongly to practice that calculation at least a couple of times to ensure that you get the stuff very, very well ironed, and you get the formula piece also, that you don't have to memorize the formulas because it's understandable. A few of them are like very easy, EV, AC, and the CPI, SPI, right? But it needs more practice because in the exam, you probably know how to solve it, but you will not be having the time to really go through the entire question and solve it one by one. What you can, so the more you practice it, it comes like at the back of your hand, and you can look into the problem and quickly say that, this is what the CPI and the SPI is. Okay, now there is one trick which I've seen in the exam. Okay, now PMI does this a lot. What they do, they give you 4 options. Out of the 4 options, what they do, 2 will be like completely, they can be taken off. They will be like wrong, and you can see that. But 2 of them will be very close to each other. And what they will do, they probably know that candidates, they forget the formula to calculate. So they will give you one answer like 89 here, say like 0.89, and they will also give you one answer which is ACY EV, because there is a lot of chance that when you go to the exam and you are not practiced and you have not like practiced much, then you may invert the formulas as well. Like instead of CPI equals to EV by AC, you may also calculate like AC by EV, and you may think it's correct. And why you will think it's correct is that PMI will give you that answer also on that multiple choice. Okay, so let's say the answer is 1 by 2, which is 0.5, and you make the inversion like 2 by 1, which is 2. PMI will give you both the answers on the multiple choice, like 0.5 and 2. And you might be doing the wrong calculation and still you see that answer on the multiple choice. Okay, I got 2 and 2 is there in the option. Fine, great, click on 2, right? You may not realize also that that was a trick to ensure that you do the mistake, right? So these are the common traits. Know that PMP exam is being done for a very long time. PMI kind of knows the mind of the candidate, how things go with them. So they will be planting in the incorrect answers to confuse you and to ensure that you are marking them. Okay, so the only guideline which I can give for schedule and cost questions is that as much as you want to practice them, they are very easy. There should not be a single mark which you should miss on any mathematical question. Okay, so with that, let's wrap up our session number 12. First, what we learned is about schedule compression, and we have seen that it can be done in 2 ways: fast tracking or crashing. Second is earned value is standing today. What is the estimated value of work actually accomplished? I think it's clear now, right? It is not similar to actual cost. And finally, greater than 1, that is always good. Anything positive, and 1 is like more than 1 is always good for both CPI and SPI calculations and the trends. All right, with that, we came to the end of the session 12. I hope you enjoyed the session. Thank you all for watching this. Have a great day and a great time.